Yes. Any doubt regarding previous topic? If no doubt, then we'll start new topic. Should we start?
Yes, sir.
So our new topic is critical angle and total internal reflection. Critical angle and total internal reflection. Now this will happen only when the ray is going to from denser to rarer. Then only these things will happen. It will never happen when ray is going from rarer to denser. So these two are the special phenomena related to that situation only. Now you see, if the ray is, if this is the boundary, suppose, so this is some denser medium. Suppose refractive index is mu, and this is rarer medium. Refractive index is mu r. If it is air, then it will be 1. If any other medium, then it will have some value. So ray may go from glass to water, maybe diamond to water, or glass to air. So this may be the situation. Now we are considering a source of light. Suppose here is the source, or many rays we will consider. So many rays are coming out from this point object. If any object is there, then also same thing. So suppose one ray we are considering this one. The ray is incident like this. What will happen to this ray? Ray is incident normally. What will happen to this ray?
It will pass without any deviation.
Without any deviation. So whether it is going from rarer to denser or denser to rarer, no problem. If angle of incidence is 0 degree, that is ray is incident normally, it will go undeviated. So in this case, it will pass undeviated. So here this I is 0 degree, R is also 0 degree, and delta is also 0 degree, no deviation. Now we consider another ray, okay, like this we are considering this one ray. This is suppose I1. Naturally, this I1 is more than 0 degree. So it will bend away from normal. As it is going from denser to rarer, so it will bend away from normal. So the ray is bending away from normal, maybe like this. This is suppose R1. This R1 will be more than I1. Angle of refraction will be more than angle of incidence. Now take this third ray. Angle of incidence is I2. What will happen? This I2 is more than I1 or less than I1? I2 is more than I1 or yes?
More than
More than I1. How we came to know? From the figure it is clear, no? Any geometrical proof? Yes.
Adjacent and
Adjacent angle is there.
alternative
If you consider
alternate angle.
angle,
Distance width is more.
yeah, this whole angle is the exterior angle for this triangle. So 90 plus I2 is more than 90 plus I1. No, 90 plus I2 is how much? 90 plus I1 plus this angle. So naturally it is more than. So I2 is more, as we keep on moving this side, so means ray is inclined like this, angle of incidence will keep on increasing. What will happen to angle of refraction? Will it be more than R1 or less than R1? Yeah,
More.
more than R1. As angle of incidence increases, angle of refraction also increases. So this R2 will be more than R1. So what I want to explain is, if we keep on increasing the angle of incidence, angle of refraction will also keep on increasing. There will be a certain angle for which angle of refraction will become 90 degrees. So this particular angle we call critical angle. IC or C, whatever symbol is used in the book. In some book it is IC, in some book it is C only. Okay. So this particular angle for which the refracted ray become parallel to the boundary. Here 90 degree means it is 89.99999 degree like that. Then only we will be able to see. If exact 90, then it will be just like dot only. Nothing will be visible from this side. So that is the meaning. So that we say the ray is parallel to the boundary, refracted ray. So this particular angle of incidence in denser medium for which refracted ray become parallel to boundary or angle of refraction become 90 degree, this particular angle of incidence we call critical angle. Why critical angle? Why this name? Because if we increase this angle of incidence, if we go beyond this IC, what will happen now? If we go beyond IC, if this angle is more than critical angle, where will the ray go? Will it go that side?
No, sir.
It cannot go because angle of incidence increases, angle of refraction also increases. Maximum angle of refraction is 90 degree. So now the phenomena of refraction will not take place. That's why name is critical.
Like in the same medium.
So that's why here name is critical angle. This refraction will take place up to this particular angle. So maximum angle of incidence for which refraction is taking place when the ray is going from denser to rarer. That is critical angle. So that's why name is critical. Beyond this, refraction will not take place. Beyond this, what will happen? The ray will be
Reflection.
reflected.
The reflection.
And it will follow the same law as the law of reflection. That is, angle of incidence and angle of reflection will be equal. So this phenomena we call total internal reflection. This will happen only when the angle of incidence is more than critical angle, and the ray is going from denser to rarer. If the ray is coming from rarer to denser, never total interreflection will take place. It will happen only when ray is going from denser to rarer. So this is about critical angle and total internal reflection. So sometimes definition is asked, definition given in your book. So how will you define critical angle? Is the angle of incidence in denser medium for which angle of refraction in rarer medium is 90 degree. For which angle of refraction in rarer medium is 90 degree. Okay, so like that you can say, or for which refracted ray become parallel to boundary. For which refracted ray become parallel to boundary. Okay, so either refracted ray become 90 degree, sorry, angle of refraction become 90 degree, or we can say refracted ray become parallel to the boundary. So when it is exactly 90 degree, what will be? Ray will not appear from up. Simply one dot will be there. Nothing will be visible from up. So here 90 degree means what? We are considering 89.999999 like that degree. Slightly less than 90. That is also parallel. Okay. So that is the meaning. Means physical meaning we can say. And when the angle of incidence become more than critical angle, then this phenomena takes place. And that phenomena we call total internal reflection. So it is the phenomena in which incident ray return to the same medium following the laws of reflection. While going from denser to rarer medium. So in this phenomena, it will return to the same medium, that is in denser medium only. and it will follow the laws of reflection. That is, angle of incidence equal to angle of reflection. Incident ray, reflected ray, and normal all lies in the same plane. So these laws will be valid under this situation or in this condition. So what is the condition for this total internal reflection?
Angle of incidence should be more than critical angle.
Yes, one is that one, and second is the ray
Ray
must
should
go
be
from
denser to rarer.
denser to rarer. So these are the two conditions. If these two conditions are satisfied, then only total internal reflection will take place. Conditions for total internal reflection. So first and second two conditions are there. So just write yourself. So one will be angle of incidence is more than critical angle for that particular pair. Each pair has got its own critical angle that we'll find afterwards. So first is angle of incidence must be more than critical angle for that pair. And second is from denser to rarer. Now, sometimes it is asked, what is the difference between this total internal reflection and reflection from plane mirror? So total internal reflection and reflection from plane mirror. What is the difference? What will you write? One will be the angle of incidence here. It should be more than critical angle here. Whatever the angle may be, whether it is 0 degree, then also reflection will take place. Whether it is 5 degree, then also reflection will take place. But here, it is not applicable for all the angles. So first will be total internal reflection. Okay. It takes place only when the the angle of incidence is more than critical angle. Here what will be? It takes place for any angle of incidence. So whatever the angle of incidence may be, mirror will reflect. In case of total internal reflection, as the ray is not going from one medium to other, transmission is not taking place, naturally absorption will not take place. So 100% light is reflected, whereas in case of mirror, what will be? Some light will go to the inside also glass plate. We have seen in case of mirror. So there will be some absorption. Multiple reflection may take place. That will depend on the thickness, how much thick it is. But there will be some absorption. Result, the image will be less bright. Here, as 100% light is reflected, so image is more bright. As all light are reflected and no light is absorbed. Okay. Here we are talking about energy only. In this case, image will be less bright as some of the light is always absorbed. Any other difference? Sometimes it is asked why reflecting prism forms image brighter than plane mirror. That is the reason. Reflecting prism means it is based on, it is forming the image due to total internal reflection. And when it is total internal reflection is taking place, naturally the light is not absorbed, so 100% light is reflected. So naturally image will be bright. Any other difference? Here, no polished surface is required. Ray going from glass to air, polished surface is not required. But here, polished surface is required. So no polished surface is required. Here it will be polished surfaces required. Now we'll derive the relation between critical angle and refractive index. Sorry. So what is the relation between critical angle and refractive index of the two medium? Two medium means denser and rarer both. It will depend on both the medium, not only one medium. So first we derive that relation. So suppose the ray is going from denser to rarer. And when it is incident at an angle of IC or C, the refracted ray become parallel to the boundary. So up to this angle, from 0 to this angle, Snell's law is valid. We can apply Snell's law. But beyond this angle, Snell's law is not valid because another phenomena is taking place. That is total inter-reflection is taking place. So up to here, we can apply Snell's law. So if we apply Snell's law, what will we get? So sine IC over sine R is refractive index of what? Yes.
Denser
Sine
to
I by sine R is refractive index of
Refractive index of denser.
second medium with respect to first medium. And what is second medium here?
dense.
Rarer. This
Rare
one.
ones.
Rarer.
Maybe air, maybe if it is going from glass to water, then water will be the rarer one. So it is refractive index of rarer medium with respect to denser medium. Or it may be 1 by refractive index of denser with respect to rarer. Principle of reversibility. Refractive index of rarer with respect to denser is 1 by refractive index of denser with respect to rarer. Now sine IC R is 90 degrees, so by sine 90, this is either this or this, whatever you may say. 1 by refractive index of denser with respect to rarer. Or it can be mu R over mu D also. Refractive index of rarer with respect to denser. So refractive index of mu R by mu D. So sin IC, sin 91, that means this sin IC will be, either we'll find refractive index of denser with respect to rarer, so this is the general formula, this is the general relation between critical angle and total internal reflection. Okay. So it is very clear, it depends on both the refractive index, not only denser medium's refractive index. If second medium is not given, then it is understood it is air. If rarer medium is not given, then it is air only. So we calculate some of the critical angle. So critical angle for glass air interface, or sometimes it is asked critical angle for glass. Means if second medium is not given, glass with respect to what it is not given, so it is understood it is with respect to air or vacuum. So what will be? So this sin IC is how much? In place of rarer, what will be refractive index of air by refractive index of glass? So if you see from the table, the value of IC you can find. So this IC will be approximately 42 degrees. This value we have to keep in mind. Exactly, if you will find that it will become 41 degree, 54 or 55 minute or 56 minute, like that will come in. So it is nearly 42 degree. For water air, what will be? So it is 1 by 4 by 3, so 3 by 4 it is 0.75. When you substitute the value, then it is coming nearly 48 degrees. That is when the light is going from water to air and angle of incidence is less than 48. Refraction will take place. That is, it will emerge out. But while going from water to air, if angle of incidence is more than 48 degree, total internal reflection will take place. So it will not emerge out in air. Similarly, glass air. If angle of incidence is less than 42 degree in glass, refraction will take place, so it will emerge out in air. Whereas if angle of incidence is more than 42 degree, angle of incidence is more than 42 degree, then what will happen?
Reflection.
Reflection.
Total internal reflection will take place. So this is glass, water. Now suppose it is going from glass to water. That will be refractive index of water over refractive index of glass. 4/3/3/2. So when you will find this value, it is coming nearly 62 degree. And for diamond air, -24 degree. So these four values you have to keep in mind. Because reasoning type question is sometimes asked. In that case, you are supposed to give this value also. That will be better. So for glass 42, when we are saying for glass means what? Glass to air. For water 48 means from water to air. So you see here what is happening. When glass air was there 42 degree. When we change the one medium, air in place of air, we got water 62 degree. That means critical angle will have a particular value for a pair, not for only one. For pair of medium, it has got a particular value. Okay, so we'll leave up to here.
Sir,
Yes.
sir, if it is exactly critical, then it is said total internal reflection.
What happened?
Sir, if angle of incidence is exactly critical angle, then it is said total internal reflection.
No. Then it will become parallel to the boundary. So up to here refraction will take place. If angle of incidence is more than this, then only critical angle, sorry, total internal reflection will take place.
Okay, sir.
Yes, any other doubt? No.
Thank you,
Thank
sir.
you, sir.
Okay,
Thank
thank
you, sir.
you.
Thank you, sir.